From the beginning, what is science? Science is the study of the natural world. Scientists study everything from the deepest parts of the ocean to the objects in outer space. Some scientists study living things, others study forces such as gravity and magnetism. Name anything you see around you, chances are there's a scientist who studies it. The natural sciences are divided into three areas: biology or life science, geology or earth science, physics or physical science. The three areas differ in the subjects they study and the methods they use. Biology is the study of living things. Biologists study everything from the tiniest organisms to human beings. Geology is the study of Earth, what it's made of, and the processes that shape it. Physical science is the study of non-living matter and energy. Chemistry often is included under physical science. A scientist's work sometimes may overlap two or more areas. For example, a biologist often must know chemistry to understand the processes of living things. Each of the photographs below relates to one of the areas of science in some way. From the captions, can you identify which area each belongs? You may think that you read a science book, you may think that what you read in a science book is accepted by everyone and is unchanging. That is not always the case. The facts of science are simply the most widely accepted explanations. Scientific knowledge is and probably will be changing. What we learn when we study science, or what most scientists agree, are the best explanation of things happening. They are theories scientists have about the world. Commonly, we think of theories as a guess or a hunch. In science, a theory is much more. A scientific theory is an explanation supported by a large amount of evidence. Theories are often what most scientists agree to be the best explanation based upon what we know. The table below lists three important scientific theories. Each theory relates to one of the areas of science described before. Each also corresponds to a photograph on the previous page. Can you think of what kind of evidence would support each theory? Not a theory. How do scientific theories differ from laws? To understand the nature of scientific knowledge, you must understand how scientists use certain words. Often the meanings are very specialized. Law and theory are two familiar words that have very specific meanings. Laws describe principles of nature. A scientific law is a description of a specific relationship under a given condition in the natural world. In short, scientific laws describe the way the world works. They hold anywhere in the universe. You can't escape them. Boyle's law is one scientific law. According to Boyle's law, at a constant temperature, as the pressure of the gas increases, its volume decreases. To get an appreciation for Boyle's law, think of to get an appreciation of Boyle's law, think of how it would feel to squeeze a particularly deflated beach ball. If you would apply pressure by squeezing, the volume or the size of the ball gets smaller. You can feel the effects of Boyle's law. A membrane or eardrum separates your middle ear from your outer ear. Normally, the air spaces on either side are at equal pressure, but sometimes the pressure on the outer ear can change. For example, a scuba diver in the photo feels an increased pressure on her eardrum as she descends in the water. By holding her nose and blowing gently, she can force more air into her middle ear. The action momentarily opens the eustachian tubes connecting the middle ear and the throat. This allows more air from the mouth to rush into the middle ear and equalize the pressure between the two spaces. It's a law. Theories describe how things happen. While laws describe what happens, scientific theories attempt to explain how things happen. A scientific theory is a well-supported explanation of nature. Theories help us understand the laws we observe. For example, The kinetic theory of gases can explain Boyle's law. The kinetic theory describes a gas being composed of quickly moving particles. The particles of gas constantly bounce off the walls of the container they occupy. The pressure of the gas increases more frequently the particles bounce off the side of the container. Two factors increase how frequently the particles of the gas will bounce off the walls of the container: temperature and volume. If the temperature of the gas increases, the particles move more quickly. The particles, therefore, come into contact with the container's wall more often. Decreasing the volume also increases the encounters between the particles. Decreasing the volume also increases the encounters because the particles have less distance to travel before hitting the wall. The container wall can be anything: a metal cylinder, a beach ball, or your eardrum. The illustration below will give you some of the ideas on how this works. It's your evidence. Where do scientists get their evidence? Scientists are curious. They look at everything going on around them and ask the questions. They collect any information that might help them answer the question. Scientific knowledge is based on empirical evidence. Empirical evidence is all the measurements and data scientists gather in support of a scientific explanation. Scientists get empirical evidence in many different places. Generally, scientific work is categorized as field or laboratory work. In the field, generally, gathering empirical evidence outdoors or where conditions cannot be controlled is known as working in the field or field work. Field work gives scientists the opportunity to collect data in an original setting. Biologists and geologists do field work. A biologist might observe how animals behave in their natural environment. They may look at how the animals gather food or interact with other animals. A geologist may be interested in the minerals in rocks found in a certain area. They may be trying to determine how the rocks formed. In a laboratory, scientists have the opportunity to collect data in a controlled environment. Unlike in the field, laboratory allows scientists to control conditions like temperature, lighting, and even what is in the surrounding air. A laboratory is where scientists usually do experiments. In an experiment, scientists try to see what happens under certain conditions. A chemist might be trying to see how two substances react with each other. A physicist might study the energy flow of a new laser. Even scientists who mainly work in the field, like paleontologists and geologists, may wish to look at a bone or a rock in a laboratory. The laboratories come in many varieties. They can look like the ocean, they can look like an ocean or the sky. Robotic laboratories may even be sent to Mars. The debate continues. How do scientists' ideas change? Recall that scientific knowledge is agreed upon knowledge. It is what scientists think are the most likely explanations for what we see. Over time, these most likely explanations can change. Sometimes these changes are very large. More often they are very small. Why do scientific ideas and explanations change? It's usually because new evidence was found or someone found a better way to explain old evidence. By new evidence, the theory of atoms is a good example of how new evidence can modify an established theory. By the mid-1800s, scientists agreed matter was made of atoms. However, they were not sure what atoms look like. At first, they thought atoms probably looked like tiny solid marbles. They assumed atoms of different substances probably differed by their mass. Later, evidence suggested that atoms most likely contained even smaller parts. Scientists observed that these smaller parts carried electrical charges and that most of the atom's mass was concentrated at the center. Scientists still saw atoms as extremely small and still often treated them like they were tiny marbles. They came to realize, however, that to explain how atoms interact in the best way, they needed a more complex picture of them. Today, scientists are still trying to refine the picture of the atom. Much of what they do involves literally smashing atoms into one another. They examine the patterns made by the crashes. It is almost like an atomic game of marbles. By collaboration and debate. Most scientists do work in isolations. They collaborate and share ideas. In a way, all scientists are trying to solve a puzzle. Often, many brains are better than one when solving a puzzle. Scientists regularly gather at meetings to discuss and debate ideas. This helps them to come to an agreement on their ideas. Many ideas are not accepted at first. It is nature for science to question every idea. Many times challenges are even welcomed. This rigorous evaluation ensures scientific knowledge is solidly supported.